All right, welcome to our next video in our series for programming Java. This assumes that you've had some introduction to Java, that you've maybe done Hello World, so you've gotten some code, some text, I should say, to appear in the console, and you're ready to start writing more complex programs, things that aren't just a single print statement, but more evolved programs. It's worth noting that the act of programming involves making a lot of mistakes and going back to revise those mistakes, debug your program, see what you did wrong, learn from it, improve your code, and continue. And it can be, I think for the new programmer, it can be frustrating. We can get a vision of the code that we want in our head. We want to just be able to lay down 20 lines of code, hit compile and execute, have them run. And I'm here to tell you, after years and years of working with Java, programming in general, it's okay that our code breaks, and that teaches us something, makes us better programmers. So in preparation for all of the breaking that our code can do, we want to discuss the various errors that can come up. And I think it's useful to give them names so that when we're talking about what we think is wrong with our code, we can say, oh, I think I have a syntax error or a logic error or a runtime error. And so we're going to introduce those terms, define them, and see some examples in this presentation. So if we were in my classroom, we'd do a little something called previous learning, where we recapped what it is we knew beforehand. I would say we should have a gentle idea, an introductory idea of what Java is. We should have set up an IDE to develop code in before this. I would recommend BlueJ or Eclipse. Those are both great starter IDEs to work with. We should have done Hello World. I think that's the previous learning we should have done before this. So my goal for this presentation is we're going to define 4 terms. By the time this video is done, you should have an idea for how to define a syntax, logic, runtime, or design error. And the term design error is one kind of my own creation, which I'll talk about when we get there. And then we want to look at some examples of syntax errors as we are first learning what the words and symbols and characters we use to make the code are. I would say that the syntax error is the most common one first. As we become more proficient, there are more subtle errors that we're going to come across, like logic and runtime errors. And then when we become very good, it'll be not a question of did the code crash or give a bad result, but did we write the code in a nice way? So hopefully you've seen this before. This is the text for Hello World. And I know that Java, in compared to other programming languages, say Python, certainly appears complex out of the gate. We have yet to define why we have to say public static void main string args. But over the course of learning Java this year, you will understand why all of those words are there and what it means to reuse those words in other places in your program. But the summary of this is, if I write this code into my IDE, compile and execute it, we should see Hello World appear in the console. You've probably noticed when you tried Hello World, if you get even the tiniest thing wrong, it doesn't work. So if I forget to put in class, if I don't have the curly bracket in the right spot, maybe I forgot to capitalize system. If I misspelled any of these words, did I forget a semicolon? Did I forget to close my curly brackets? Java is really touchy. So it's probably worth defining at this point, what do we mean when we say syntax? Syntax is a word that I think gets probably used in English classes rightfully about the ways we compose our words, right? Our sentences, that's your syntax. Syntax in programming is what is the correct words or characters so that you can compile and execute the logic you're trying to take care of. Something that you will encounter is that human language, the human brain, is pretty forgiving. There's all kinds of internet puzzles out there that give examples of how you can kind of scramble up the words of a sentence, but as long as the first and last letter are the same, you can still read it, right? So the human brain has the ability to make quick corrections to process whatever information it needs to. Computers are not that forgiving, and especially the compilers whose job it is to take the code that we've written and translate it so that the computer can use it. There's a joke that if books were like code, if you were missing a period on page 37, then no part of the book would make sense. And I wish I could tell you that that's not true, but that's a pretty good example of how it works. Everything needs to be in the right spot in order for the code to work. And if we're missing a semicolon at the end of a statement, if we had an open curly bracket opening maybe a method block, but we don't have a closing curly bracket to close that method block, that's an example of a syntax error. They're the most glaring because code won't run as long as there's a syntax error. And they're sort of the first wave of things that we have to figure out. I like to include Yoda on slides that deal with syntax because Yoda has a very famous style of syntax that he uses, right? Do or do not, there is no try. That's not how most of us speak. And it just goes to emphasize, if we can understand what Yoda's trying to say, we can understand the Java syntax that we're trying to teach. So if you're spelled something wrong, missing a character, the actual text that you've put in your program, if it's wrong, that's called a syntax error. Right. Syntax Yoda. So what are examples of syntax errors? If you said the name of your file should be laser blaster, but then in the program you wrote public class laser shooter, that would be incorrect. If you forgot to capitalize the S in system, that would be incorrect. If you misspelled the word main, that's incorrect. All of these are examples of syntax errors. If you forgot the semicolon at the end of a statement, if you didn't close a string by you had one quotation mark, but you didn't have the other, well, then that would be an example of another syntax error. So what are you going to do? How do you attack syntax errors without getting overwhelmed? The habit that you got to get into, and it's always hard for new programmers to want to do this, is you got to stop and compile your code every 2 to 4 lines. Like write a few lines of code, and then I'll teach you the hotkeys for BlueJ or for Eclipse to just say, hey, did I do anything wrong? Am I missing anything? Because fixing a single syntax error, not so bad. But if you made 4 or 5 and they're spread across, line 37, line 120, and line 122, it can be pretty hard to figure out what's going on. This is true for syntax errors. It's especially true for other kinds of errors where the code is all correct, meaning that we use the right wording, but the commands that we're giving are going to cause a problem, and those will create logic or runtime errors, which I'll cover later. It's especially important to compile often to catch these sneakier errors, because if you have 5 or 6 errors lurking in the background, sometimes you almost have to just delete entire chunks of code and restart if you can't untangle what the error is. When you have multiple errors to work with, I'd say the other piece of advice, don't try to do the entire piece of code and see if there's a connection between all the errors. Start with the top error, fix it, go to error number 2, fix that, go in order, and then it won't overwhelm you. So a logic error is an example of when a program behaves, meaning it executes and it runs, and but the result you get is not what you wanted. And this is something we call a bug. This is named after the legendary and wonderful Admiral Grace Hopper. Not only was she an enlistee in World War II, became an admiral in the Navy, but she got to work on MIT's Mark II computer where an actual moth blew out Relay 70, and she taped it to her journal, which you can see here, and wrote the words, first actual case of a bug being found. So the reason that we call mistakes, whether they be in computing or anywhere else in life, the reason we call them bugs is because of this wonderful woman right here and her contributions to computing. Logic errors means your code worked, but it didn't produce the results you wanted. And an analogy I like to give that describes the difference between all the errors is if you had to build a car and then drive it to perform a task. A syntax error is you couldn't even build your car right. You didn't have the parts in the right place, and you go to turn the car on, and it just doesn't work. So syntax error means you put the engine on the roof, or you put the wheels inside the car. You did something wrong. Car can't even run. A logic error is where you got the car to turn on, and you got it to drive down the street, and you were trying to get it drive it to the grocery store, but at one point you gave it the command to turn right when you meant for the car to turn left. And so instead of ending up at the grocery store, maybe you end up at the gas station. Now the car didn't crash. It was able to start. It reached a destination. It just wasn't the right destination. And so turning left, turning right, both valid commands, but you just switched those. You just gave the wrong command. So we would say a logic error is you don't get the result you want, but you gave valid commands. Debugging is the process of finding and eliminating these bugs. Some people consider runtime errors to be a subset of logic errors. Just so I don't confuse my students, I'm going to think of them differently. A runtime error is going to specifically be the term that we use to describe when the code runs, but something we do while running causes it to crash. So we built the car correctly. We're asking for valid commands, right? Gas, brake, turn left, turn right. All valid ways of driving a car. But at some point when we were driving our car, we told it to turn left, and turning left makes it crash into a tree or something like that. That's an example of a runtime error. Turn left, perfectly valid. That's not a syntax error. And it's not a logic error because we didn't get to continue execution. I'm going to say it's a runtime error because a command that we gave that appeared to be valid caused a problem. Famous examples of runtime errors in Java include dividing by 0. And because the way this might look like an invalid command, but the way the compiler views it is it's not going to do the math. It's just going to make sure that you put a valid symbol in that statement. So System.out.println, that's all a valid statement. And then you've got this division operator between two things. The compiler isn't going to go check and see if you did nice math. It's just going to say, oh, division. I need a number on the left side. I need a number on the right side. I don't care what they are. I will calculate what those are at runtime. But I will sign off that this is correct. This is good syntax. And then that's the problem where the car turns on, you drove it, and then you tell it to divide by 0. Bang, crashes into a tree. Examples of other runtime errors are if you tell your program to go looking for a file that you've promised was there, and when Java goes to look, it can't find it. Because you promised it was there, it was a valid command, but because it wasn't in the folder that you told it to be in, it crashes at runtime. Other examples might be, let's say you're looking at a collection of numbers. We might call that an array of numbers, and you say there's 10 numbers in this array, and you say go look at the 11th number. Well, it'll say, oh, 11 is a valid number. Surely there must be 11 elements in that array. But come to find out there's only 10. It goes looking at a memory location that doesn't exist. That's another example of a runtime error. So syntax, you try to drive the car crashes. Oh, excuse me. Syntax is you try to drive the car, and the car won't even turn on because the car is built wrong. Logic, the car turns on and goes to a destination, but because you gave an incorrect command, it just goes to not the location you wanted. And a runtime error is while driving the car, you tell it to do something that causes it to crash. This brings me to the last and final one. Now, you won't find this term in the textbook, but it's something that I ran into over and over and over again so often that I thought, man, I'd better assign a name to this. And that is ugly code. So on the screen, we see an example of code that was written with no indentation. Now, the syntax is valid. This code runs. It's actually, I think it's probably worth noting that this is a markup language, and some people would object to characterizing this as a coding language, but I just like to give it as an example. There's no indentation, which means that we can't tell what tags, what blocks are inside of other blocks, and the resulting problem is it makes it very hard to read. Design error is you turn the car on, you ask it, you give it a series of commands, and all the commands are valid, and it goes to the grocery store like you asked. But it is so ugly, it is so disgusting that nobody wants to get in your car and use it. They can, if they can tolerate it. But I don't know, it smells like old moldy cheese, or it is like a really heinously ugly color. But basically, the machinery works right, but everything is so unappealing, unusable, that people will not want to use it. And the further problem is that if you need to build on it, if you need to ask it to do anything else, design errors often make code so unusable that you can't make new additions. We say that good code should be readable, maintainable, and extensible, meaning that I should be able to understand what I'm trying to do with it. I should be able to make any changes I need to. I should be able to maintain the code as needed. And I should be able to extend onto it. And anytime I make crimes of design, crimes of style might be the other way to describe it, we make it very hard to change our code. All right, we can ignore that last slide for now. So those are the 4 types of errors. Just to recap: syntax, logic, runtime, and design. Going forward, as you work on your code, if something breaks, you can now use these terms to describe what's going on. Hey, my code works, but it came out with a weird result. It crashes when I'm running it. I don't have the syntax right, or my code is so ugly I can't understand what it's doing. Those are the 4 types of errors. Thanks for watching.